Hello, everyone. Welcome to another BAF virtual event. Today, I'm very excited because this is our second event in collaboration with Blockchain at Michigan, and in particular, our awesome Ishan. And I'm going to let Ishan introduce our speaker for the day and the topics. And if you have questions, there's a Q&A button on the right corner of your screen. Please drop your questions there. There's also an interactive chat, so feel free to use that as well. And yeah, after the event, we're gonna have a networking session. So if you want to stick around and meet cool people and chill, it's always good. And yeah, that's about it. Ishan, you can take it away.
Yeah, for sure. Thanks for hosting this event, PG and Blockchain Acceleration Foundation. Today, I am beyond excited to introduce one of my kind of personal heroes, Anatoly Yakovenko, and I do apologize if I butchered your name. But let me just introduce Anatoly a little bit. He started off graduating at University of Illinois Urbana-Champaign, graduating in 2003 with a bachelor's in computer science. And since then, his career has mostly been as a software engineer specializing in distributed operating systems. So he climbed the ranks at Qualcomm for 13 years, and more recently, he started Solana, which everyone knows and loves, about 3 years ago in October 2017. And yeah, with that, I think we can get started, Anatoly. I know you said you wanted to talk a bit about how Solana got started and applications, who's using it. We can't wait to hear from you.
Awesome. Thank you so much. That's a great intro. I'm Anatoly, co-founder, CEO of Solana, and I can kind of get into how Solana was founded and the basic principles behind it. So 2017, like we had this big blockchain boom, and myself and one of the Solana co-founders, Steven, we had this silly startup to build deep learning hardware like racks of GPUs and offset the cost of that hardware by mining crypto in the background. So while this thing didn't have jobs for deep learning, you could at least pay for the hardware. So it was doing something. And this is how I started thinking about proof of work, why it's so slow, and why consensus is such a kind of hard problem, an interesting problem. And as the legend goes, I had, coffee and two beers, or two coffees and one beer. And I was up and I had this like kind of eureka moment that you can take the technique that's used in proof of work, which is SHA-256, but instead of using it as a way to measure electricity or like this massive amount of kind of entropy that goes into proving Sybil resistance in Nakamoto consensus, you can actually generate a data structure that represents the passage of time. And this was a eureka moment for me because given that I spent majority of my career at Qualcomm, time is like the thing that you optimize first for in wireless protocols. If you guys have an intuition or remember any of these classes on wireless protocols, you have two towers transmit at the same time over the same frequency, get noise. And one of the first approaches people tried is give each tower a clock, and they can alternate by time and therefore reduce interference and therefore reduce collisions. And this is the same thing that happens in blockchain networks when you have two block producers producing a block at the same time. So that was really it. Started Solana and was lucky enough to have worked with a bunch of really amazing folks at Qualcomm that built operating systems, worked in the LTE spec, built like the GPU like infrastructure for mobile phones and compilers and basically every part of what you'd need to build this high performance layer one. So we built it basically like in a span of 2 years, 200,000 lines of crust, a lot of sleepless nights, and launched in March, and it magically kind of works. So that that was surprising. I mean, it was a lot of work, but also we're super excited that like it kind of came together. So I can give you guys kind of some demos if this makes sense. Strange. Oh, bummer. Okay, I think to share my screen, I need to actually quit and come back. Is that just kind of strange? Let me see. Is that Ishan? Is that okay?
It should. It's working for me. Did you join with the speaker?
Yeah, I did. It's just the permissions on OS X to share screen for Chrome require me to quit and come back, unfortunately.
Okay, yeah, I think that should be fine.
Okay, which is okay. Okay, I'll be back in 1 second.
And while we're waiting, okay.
Yeah, I thought I didn't want you to be alone. Yeah, it's sad that this happens, but I guess Anatoly is gonna be. Oh, he's actually back, so
Okay, that's impressive.
I'll disappear again. Bye.
It's fast like Solana. Ooh, it's me times 3. It's like recursion at this point.
Perfect. Okay, you guys can see it. Can see the screen. I think. Perfect. So I'm gonna go see if this is still showing. Does it show the break.solana.com?
Yeah, and you guys, everyone else can click full screen on Anatoly share screen.
Okay, so this is like a demo that we built to kind of demonstrate how Solana works. And we're trying to think like, what is a fast blockchain? how do you show that to humans? So we built this like little thing, a game where every time you press a key, it sends a transaction, and when that thing turns green, it means that it was confirmed by a cluster, by the global network. So I'm just basically going to smash the keyboard as fast as I can, and you guys should see transactions being fired off and confirmed. And this costs about like 5 cents worth of Sol. So this is the client, right? It sends a transaction and it gets a notification that the network actually came to some settlement on this thing. And this isn't just like some fake transaction or anything like that. This is a smart contract called Break, and you can go to the Explorer. Sometimes the Explorer is a little behind. Well, demos always work, right? So these are smart contract transactions that get sent by this cluster, and if you can actually look at the network as it's distributed here, which is this globally distributed state machine where everything is replicated. And our PC nodes are like kind of like our Infura, which then can read some of this data from as it's indexed by Bigtable. So our PC is actually slightly behind the network, which is kind of a fun problem optimizing for writes and reads at the same time. But this is a smart contract that was loaded and confirmed from the client side, and it loaded a user supplied program, which is represented as a Berkeley packet filter executable file, an ELF. That thing has an entry point, calls into it, does a state transition, and that state transition is confirmed by the supermajority, and you see this thing light up. And the supermajority is based on the stake weight as it's distributed across these data centers and kind of users that are running machines. There's, I think, around 370 validators on our mainnet, and our testnet, where we stress test things, has about 570 or something like that, but it's currently being restarted. So that's Solana. Basically, we kind of made this bet that we can build a faster, more reliable blockchain by using the same techniques that we learned at Qualcomm, which is shard the time domain and slot the block producers so they basically reduces the possibility of them transmitting a block at the same time. And then within the block itself, these transactions are defined such that the runtime knows ahead of time which accounts this thing is going to read and write during execution. So when you look at this account inputs, the runtime as it's executing is able to horizontally scale that execution because it knows that all the other transactions that don't read or write these specific accounts can be executed in parallel. So this is how we implement transaction isolation. And therefore we can just run as many things concurrently as possible. So if you go to like exploresolana.com, right now executing about 1,000 transactions per second. The total since March is over 5 billion. Our block times are tracking around 340 milliseconds, or 400 over the last hour. So it's usually somewhere under 400. And it's nearly 50 million blocks. So a bunch of those transactions are votes because our consensus engine is so optimized that we actually use it. A runtime, like just the smart contract execution layer, is so optimized that we use it for consensus. So this is kind of a really cool side effect of our approach to scaling is that like the fundamental thing that we're scaling isn't just TPS for TPS sake. It's actually how many of these validators globally can communicate with each other, meaning that how many of them can vote and participate in consensus. And the key part here is that as we grow the set of validators, we get to use the same like techniques for scaling this set as we do for TPS and for every other application. And that means that when Moore's law, like when CPUs and GPUs double in capacity, we can basically double the size of the nodes participating in the network for free. Like NVIDIA just released a GPU card that has 10,000 cores. That thing benchmarks at 7 million signature verifications per second. So one of our validators built a system that showed that it has peak capacity that's measured like at 1 peak second that hit 2 million TPS, but on average about nearly 300,000 TPS over like a 20-minute run. So basically, like as hardware improves, this is kind of our thesis. Intel, Qualcomm, NVIDIA, AMD, they're going to continue shipping better hardware, more cores. TSMC is going to continue shrinking the process. The wafer sizes are going to double. So you kind of get the cost of organized sand just gets cheaper and cheaper every 2 years. And we can leverage that to either increase the capacity of the network, but also increase the decentralization, the censorship resistance. Because when we have twice as many validators, twice as many people that are verifying this, replicated state, that's twice as much security, twice as many like things that need to collude or need to be broken into to break the security assumptions of the network. And at some point, the set is going to get so large that somebody that is like chief security officer at Visa or Bank of America, when they look at this network, let's say it's 10,000 machines, it's basically becomes impenetrable, from their perspective. Like right now, 370 validators, you can kind of imagine that there's some way to attack all of them quickly enough before that's detected. But with 10,000 independent validators, that assumption, kind of falls away. And you end up with a universal computer that is like, you would use this over any other thing that you could build privately. There's some point where it flips from public permissionless network are riskier than a private one. So this is what we're building for ultimately. And the use cases for this are, so if you guys, I don't know if you guys have heard of FTX. They're one of the largest derivatives exchanges. So Sam Bankman-Fried, who runs it, he kind of had a similar idea that these networks are going to get faster and cheaper to the point where if you have a universal computer that is just fast enough to run an exchange, that's going to be a better exchange than a centralized one, because of the privacy and the security, but also the kind of the financial composability of using something like a smart contracts platform. So we showed them our demo, and they've actually been looking for a bunch of looking at a bunch of networks to try to launch an exchange on top. And we're, I think, the only one and the first one to be actually fast enough for that kind of execution. So in about 4 weeks to build a full central limit order book. So the main functions of an exchange is to do this, receive orders from market makers and to guarantee that they're filled by price time prioritization. So this is different from an automatic market maker like Uniswap, if you heard of that on Ethereum. The main difference here is that you have a market maker like Jump Trading or Alameda that is taking risk with positions and constantly updating them. So when you see these blips on the screen, this is a Solana transaction that changes the price of an order. So the network needs to be fast and cheap enough to do this, such that the market makers can take risk with these positions. And the cool thing is, like, what we love to do is make the system faster and cheaper, and then lower the latency that we can guarantee with this global execution. The better the spreads that and the higher volumes of risk that these market makers can take. So it's kind of this, self-beneficial loop of us making the system cheaper and faster with hardware, and them being able to take more risk. The cool thing is, at some point, our block times here might get down to the theoretical limit of the speed of light of fiber around the world. And if that happens, then a state transition running in Solana basically travels as fast as the news. So if an event happens, let's say in Russia, where like oil, there's more oil is discovered, or an oil pipeline, bursts or something like that, that news will propagate at the speed of light through fiber to a trader at the New York Stock Exchange. But that state transition can propagate at the speed of light through fiber at the same time. And therefore, the price reflected in this market will be as good as a price on the New York Stock Exchange. So this is like the really like cool futuristic thing of like building these like cryptographically permissionless universal computers, is that they can actually approach the kind of use case that is currently like being run on a centralized system like New York Stock Exchange, and that's global price discovery. And this is, like in our first Solana pitch deck, there's literally a slide that says Solana is blockchain at NASDAQ speed. So fundamentally, like, I think this is our kind of target use case, is doing stuff like this. But DeFi is, I think, more than that, more than just trading. Like the kind of sophisticated, like, this is a automatic market maker that was built by the Serum folks, and through this, like, kind of, you can think of is an AMM a competitor to a central limiter order book. The cool thing is that this is a really innovative DeFi smart contract that allows people with like, proof that they own some asset to provide liquidity through a math function. But this doesn't really compete with this, because any kind of price that is offered in this market can also be reflected in this market by the same market makers that are updating these order books, because you can effectively trade from them. And this information that is computed by Jump Trading and Alameda to calculate the spread and distribution of how much risk there is at every price can actually feed back into this automatic market maker. So it becomes like, again, like these like really beneficial loops between information that's computed by these dynamic price updates and this mathematical function that can then use it to adjust its curve. So to me, this is like, I think, kind of like the future of finance is going to be built on these systems, because they are effectively disintermediating like all the middlemen across the entire stack. That you really don't need these like massive institutions to do this stuff, because we have cryptographic guarantees and open permissionless code that anybody can look at and simulate and know exactly what the risks are. And the financial primitives that are built here are like trustless, right? There's nobody in this smart contract that can commit fraud. And this is like a really, really powerful thing. Like I think this is basically going to change the world, because once you build these systems, they can be leveraged by every other use case that are not potentially like finance specific or trading specific. Like, for example, Audius just launched, that they're going to provide this music sharing and collaborative like application for artists and their fans to connect and kind of like trade and organize music over cryptographic networks. Well, the cool thing is, if an artist launches an NFT that represents royalties on some song, that thing can now feed into these extremely sophisticated trustless trading systems that are basically light years ahead of anything they could have done by hand, with like regulated like contracts to music producers. So this is a way to basically disintermediate everybody that is currently like rent seeking in art, in social networks, in trading. Like a social network is nothing but a community, right? That of people that are collaborating with each other. Well, imagine if they had a governance token, for jokes, for voting, for upvoting, for asking questions, for rewarding, memes. That thing will have value, and they no longer need advertisement to pay for running the network, because that token itself, because it's part of the community, is providing value just to participate in that community. That's a really powerful thing. Like right now, when you look at like governance tokens in Ethereum, there's maybe 10,000 people that participate in any of them. We can actually scale it to 100 million. And like a social network that is built around this concept with 100 million users is going to be way more powerful than Facebook, because there's no longer a need to sell these users information to anyone else. You no longer have to steal their data, because they're kind of generating their own entertainment, and that's valuable, right? Ultimately, like, what is Facebook providing us? It's entertainment, but they're siphoning our data to be able to make a profit off of it. And we don't need that. Like, we don't actually need them in the loop. This is where I think that this stuff has really tremendous potential to really revolutionize privacy, identity, data, finance, and kind of put all these things together.
That's absolutely brilliant. And it really kind of puts things into perspective when you say, hey, I don't need to be instantaneous, just as fast as the news. Diving deeper into you said that, hey, we can create a social network that derives value for everyone without extracting value in terms of data. But that's still going to cost money in terms of maintenance. So I guess it brings up the question, how does, or if Solana currently doesn't, how will Solana make money?
So So the network is a proof of stake network. So validators that are providing that are like running one of the nodes, they attract delegation, and through the commissions from the rewards, this is how they make money. So this is effectively like part of the fees get burnt. So kind of all the tokens get money when every time there's an order update, this thing makes money. But I think ultimately you have to kind of look at it from a very high level. What is this thing replacing? This is software replacing financial systems that are typically done with regulation and paper. And that regulation and paper is designed to actually implement censorship resistance. Like once you go through the hoops of getting KYC'd and getting into the banking system, you're supposed to have free and like fair access to all financial services, which is effectively like regulated censorship resistance. We're trying to do this with software, right? We're trying to make the set of validators so large and the cryptography guarantees so strong that you get the same guarantees. And at a high level, I think once we succeed, right, like once these things become sticky financial services, they should earn a reward that's comparable to the volume and AUM of actual real transfers of value between two nodes. And I think you can even almost, if I were to like hit this over the head with a hammer, our consensus is designed such that, let's say, 2/3 plus X of validators vote on a particular block, then at least X have to be slashed for that block to roll back. And this is what we call optimistic settlement. So if I transfer you money and you want this money faster and with faster guarantees, you'll actually pay to insure it against what's being slashed to the network. And that is effectively percentage of me transferring you value, right? And you paying for that. And if this is wash trading, if it's just me faking transactions to myself, I'm not going to care about the insurance because I don't care if they get rolled back. But if this is actual value transfer from different parties, they're going to want this and they'll pay for it. And at a very high level, when these numbers get large enough, some small percentage, which is going to be much lower because this is just software, is going to basically effectively pay for the network. So that's kind of like a very long-term view. In the medium term, I think these networks are still like very speculative, and the value add here is just kind of growing the users and the use case and the number of participants in the network. It's just too early for anybody to really monetize them. Ethereum is a special case because it has enough product market fit and enough users to where you see things like in the month of August, it generated 100 million in fees. But I think that's actually going to rapidly go away because of, in a lot of ways, block space, like this idea of cryptographic settlement, it's fungible. And transfers in Ethereum for USDT, those transfers between, let's say, Binance and Coinbase can occur on Solana or Tron. You already see that USDT transfers on Tron are kind of eating away at the Ethereum transfers. And you'll start see these use cases basically take the path of least resistance, like this with the smallest fees. Like the requirements, like I often talk about like scaling with hardware. Reality is that like modern day hardware is ridiculously fast. So I looked at the PS5 specs, and those are more than what we recommend for Solana validators. If there's anybody here that's like a gamer that would want to work on a port of Solana running on PlayStation 5, would love to chat with you, because that would be a super fun project. But our kind of requirements are more demand driven, and we see about 1,000 TPS per CPU core as kind of like, you can kind of guesstimate. There's a bunch of other factors like speed of the your SSDs. You don't want to be on a spinning disk, so you need SSDs. And you really like, the main bottleneck is bandwidth. So a lot of like crappy internet connections have bad upload. So like home connections, but it's getting better kind of overall in the United States. The broadband is getting better. And 1 gigabit, like a solid 1 gigabit is really like ideal. And if we have the hardware and we've optimized everything, you can stuff 500,000 transactions per second into 1 gigabit. so that is like plenty, right? And like 20 years ago, I would have sounded crazy if I told you we're going to see 1 gigabit wireless, like 1 gigabit internet in your phone. 20 years from now, we're probably going to start approaching 1 terabit speeds. So this is also like one of those things that grows really quickly, and you'll be surprised how rapidly 1 gigabit is going to seem small. So how many transactions Solana can process per second? And this is based on pure hardware. The maximum we have seen somebody build a system that has some sustained load is about 300,000 TPS. And this is a high-end system that is not accounting for network faults or some kind of bottlenecks in the networking layer. This is purely in the hardware level. So if it had enough like network cards and big enough pipe, we could theoretically handle that much. But this is still a single machine. We haven't done the work, but there's nothing in the protocol that would prevent the validator from having like a huge 42-inch closet full of GPUs. That just hasn't been necessary yet. What is the time horizon for near speed of light end stage for Solana? Decades? I think like the next 200 milliseconds are like probably a year, maybe 2. After that, I don't know. That's going to be really hard. I don't know. Like I think like those optimizations in the next 200 milliseconds, I think there's some low hanging fruit there, and then we'll see after that. Maybe like stuff gets faster than I anticipate. So who knows? 4 years. So that would be super cool. So what kind of finality do transactions have? So we implemented practical Byzantine fault tolerance with one caveat is because we can make strong assumptions about time. We've basically implemented Nagel's protocol, which is what you use in the window protocol in TCP/IP. Is this idea that you can transmit a bunch of stuff and you get acknowledgement that follows the window and kind of catches up to what you're transmitting. So at every 400 millisecond slot, there's effectively a view transition that a validator proposes. And these can kind of run ahead of actual finality. So for those like sub-second finality, if you have 2/3 plus X that respond, we guarantee that at least X have to be slashed for that block to be rolled back. And after a certain amount of these things being stacked, you've effectively reached BFT consensus, which is 1/3. So it's similar to every other PBFT chain, except that we can optimistically give you this finality that is much, much faster. How does Solana handle scalability differently from Avalanche? Avalanche is a DAG. We are not a DAG. So DAGs are, I guess one way to visualize it is DAGs don't have a dedicated block producer in any given moment in time. So where this kind of becomes challenging is imagine you have Avalanche on a 1 gigabit plane. So every node is connected, has 1 gigabit of up and down bandwidth. And on two opposite sides of the network, 2 users submit 1 gigabit each. So effectively, right, there's more state transitions than the network can handle. And because this is a DAG, this overwhelms the network, and the network has to kind of go through the slow consensus process to figure out which state is first, because you effectively have twice as many state transitions that are trying to linearize than the rest of the network can propagate. because you have 1 gigabit up and down, right? So you're physically bound at some point. With Solana, you have a rotating leader. So at any given point, there's only one block producer that's rapidly rotating. So as these things are rotating, there's only 1 gigabit that can be written at any time. So that effectively eliminates that problem. And that is a fundamental difference between DAGs and, I don't know what you want to call us, a traditional PBFT system. So the main applications are Serum. So that is a decentralized central limit order book on chain, which is really cool. It's different from like Ethereum DeFi because it allows market makers like Jump Trading, which handle, if you ever done a stock trade, they handle 80% of the stock, securities, options trading in the world. So they've probably handled your trade. So they can't use something like Uniswap because Uniswap is an automatic market maker that does not respond to news events. It responds to trades, but does not. You can't update its price dynamically. So that means that the capital that's put on risk or the spreads or the fees there have to be high enough to effectively compensate the liquidity providers for this inability to update their prices. The capital that goes into that is much smaller. But something like a long tail asset where you have a new company that just issued a bunch of shares or tokens, they don't really care whether that price that's reflected in that market is exactly the optimum price globally. So they can effectively take a loss on those trades. But with like a highly liquid pair like BTC, USDT, you basically can't. So you need to have this dynamic market making. So that's a fundamental difference between what you can do on Solana and Ethereum. And that means that the kind of DeFi applications you can build on Solana are different, right? So a margin protocol on Solana, because you're getting 400 millisecond price updates, can have much higher leverage that plugs into the most liquid pair in the world, which is BTC USDT. How do you expect trustless exchanges to ramp identities to be compliant with regulators? That is I think still an unanswered question. That's pretty hard. I think there's some progress that's being made there. It's just slow, and some obvious ways to do this is you can kind of whitelist a bunch of participants and create a single market where only whitelist participants can trade, and that works to some extent, but that's really hard to grow. And I think there's opportunities to do things where, if you look at how Circle issued USDC on Solana, is that their implementation of the token contract can freeze accounts of bad actors. So there's a way to kind of build systems that I think allow a bit more individual on-ramping that's a little easier. And we'll see how that plays out. That's kind of outside of our scope because we don't build these B2C, B2 trader businesses. We're more we're like the Linux kernel, right? So we're really focusing on just make this thing faster.
Quick follow-up to that. I know there's been some chatter in the news recently about whether or not exchanges should comply with regulations, especially with Coinbase choosing to not list Monero due to US regulation. So what are your thoughts on that overall with the blockchain, within the blockchain ecosystem?
I mean, blockchains have to comply with regulations. Law is law, code is not law. Sorry. So it depends how you do it. The problem with Monero is that it is there's privacy protocols like Zcash and Aztec that run on Ethereum, and those are friendlier to regulations because I think they're not mixing services. Monero behaves more like a mixing service, which is like obfuscating privacy and not really implementing it in like a strong way. I don't know. This is a hard problem. I don't know where the trade-offs are. It depends on which lawyer you talk to. Like the kind of like trading with USDC and USDT, those are the most liquid assets. Both implement and have frozen accounts on Ethereum. So those are regulatory compliant. Like every Ethereum account transfers that go through a mixing service, like if you were to try to like obfuscate where you got ETH or some ERC20 token, Coinbase I don't think allows you to will take deposits from there. So you already kind of have like this idea that you have software that implements a universal computer, and then protocols inside that software are still open, but services that deal with humans and human identities, those are the ones that are implementing their services in a regulatory compliant way, which seems like a reasonable way to approach this. We kind of saw this in the 90s with search engines and copyright law. So effectively, like I think US and most regulators globally want to carve out some space for innovation, because I think this is really powerful. If you can have a lending protocol which can fairly assess risk and provide a mortgage that is backed by 1 million people, like without the middleman of a bank, that's a really powerful thing, right? 1 million people can take risk on a Google employee taking a mortgage in the Bay Area. That's great for everybody involved there. So to me, like this stuff is coming where it intersects like regulated like financial services, I think is where some of the adoption is slow, but it's still pretty fast. Like look at USDC, they've issued I think $3 billion dollars on Ethereum, and that's a US regulated company.
I think that's a fair answer, that you want to be compliant with the regulations involved, and then yeah, I'm not sure where to go from there. Let's see. There's another very interesting question, kind of diving deeper into the people questions behind Solana. And Adam asked this: if government tokens replace some free access, isn't that replacing free/ad supported content with paywall content? And what's the innovation in that?
Yeah, so this is like the paywall that is between artists and their fans, and how that's distributed is kind of up to that community. And the cool thing there is the innovation there that I think is really interesting is that the early access, the early adopters kind of get a lot more access for a lower price. So somebody that's an early fan that is doing a lot of work to promote like a particular artist or to create great content for their community, for their subreddit group. In those early days, right, there's not the first 20 people that join, like build stuff to get the next 20 people to join, right? They actually get more rewards and kind of more out of that community than they would with advertisement-based revenue. And that to me, I think is really interesting. So the other side of it too is that I can be a part of every Reddit group and every social network. I can generate a bunch of identities and kind of join a bunch of groups and kind of astroturf or whatever. But I can't do that with tokens because I have to spend money to get them. So it kind of like forces us to pick a set of networks. even if I can still buy a bunch of tokens if I'm richer, right, or whatever, but there's still like a limit to it. And I think that is somewhat quite different than having, like TikTok, where is famous for like everybody having 1 million followers like in 2 weeks. Like you can't you can't have everyone in the world, having a million like tokens and everything still having the same equal value. So that to me is also kind of a really interesting effect of this. But this is still really early. Like this is very much like 6 degrees in the 90s. Like, I don't know if you guys remember this, but basically this was like, hey, look, I'm 6 degrees away from everybody in the internet. And there were 40 million people on the internet.
I definitely think that as we grow, it's going to seem that rewards will be distributed somewhat unequally, but not to a fault, because you do want to support those early supporters to some degree. Another question by Robert. I think this kind of goes off with all the IPFS happening. Will Solana ever integrate a file storage system, or with having to go off chain? Or what are your thoughts on that?
So in like our white paper and like our like early designs, we had this thought of building a storage network for the ledger itself. But it turns out like Arweave and Filecoin and storage, basically a couple of projects actually succeeded in building storage as a service, permissionless storage, and using those is easier. I think like those are optimized for storage, and I think that's a separate problem than optimizing for state transitions at light speed. It's just like I don't know if you can solve both. I don't think there's a point to trying, because the easy thing to do is for Solana to run a light client for Arweave and to validate a proof that Arweave is storing some block of data that you care about, and doing the same thing for Filecoin. So this is kind of where I think integrating storage would be really useful on the Solana side. And building those light clients is just writing some Rust code to validate those headers. So that's just, that's a solvable engineering problem.
So on the roadmap soon to be able to do.
Yeah, so Arweave, like we actually use Arweave to deploy a bunch of applications because it's a really great static hosting service. I don't know if you guys like go try Arweave's PermaWeb. It's just super easy to use. So we like let's see if I can find one of those links. But like basically like maybe not. Like any of those applications that I showed, like the Serum DAX or Swap, that's you can load that from Arweave, and now that is an exchange that is persistently stored. This is runtime code that is forever stored on this permanent like block storage network, Arweave, that can talk to this, like state machine, right, engine that is Solana, and that is itself decentralized and persistent. And now you have a unstoppable application, UI and like the actual state transitions, the business logic, and it's as fast as AWS. Like from a user's perspective, bots can tell the difference, right? Bots can tell the difference when between 400 milliseconds and 80, but users basically can't, which is really cool. Like that to me is like something that is kind of still like blowing my mind. I haven't gotten used to that idea.
I know we're running short on time, so I'm going to try to transition a bit more to the high level perspective. You talked about how Solana is eventually going to become the path of least resistance in terms of fees and speed. And meanwhile, others are saying that it's impossible to have a if you build it, they will come mentality. So what do you think, aside from speed, uh speed and fewer fees, will lead users to select one protocol over others when there are many options? Yeah.
Yeah, so there is like an early mover advantage, which I think in some ways we were able to capture with like Serum and Audius. We were just live before our competitors. Like I don't know when Near and like Avalanche are going to be stable enough to onboard those folks, but like those 2-3 months extra that we launched in March instead of like at the end of the summer. Like those first 100 days with a new network, you just kind of fight a lot of fires. We were done with those, and the network was fast and stable, and we were able to like launch this really massive use case, which is a central exchange. So from that perspective, that helped a lot. I think users are not going to care about layer ones. I think there's some idea to this that the value we're providing is enabling like cryptography for humans, like individuals that once they understand that they have a private key, that it means something, and that signing with that private key means like spending cash or like equivalent to handing over somebody cash, right? Or handing cash to a service that's like a bank and lending it to a service. Once they get this, they're not going to care about layer one, layer two, which consensus mechanism that uses. What they care about is like, how do I use my cryptography here? Like, how do I use this thing that represents either my identity or value? So I think in some ways, like the layer ones are all going to be fungible. And if that's the case, then I think like cheaper, faster will be the easiest one, especially for the central limit order book on chain, because the lower the latencies, the bigger the books, like the bigger risks like jump trading can take. And if those books are bigger, that means people can take higher risk, right? Like, so the margins can go from 10x to 100x. And that's what kind of drives liquidity. That's like an engine in itself. That kind of use case, I think, is like speed is good. Like, for the other stuff, I think those are harder, but like I'm like, it needs to be fast enough to where the users can't tell the difference. I think like 200 to 400 milliseconds, users are not going to care. And then like you start you see diminishing returns from a user's perspective. And there are things like, SDKs and development tools will matter. But we haven't like seen that yet be a huge differentiator. It's hard to tell, like even things like bridges between Ethereum and other networks. At the high level, users don't really care about the implementation. What they care about is speed and somewhat reliability.
So is it fair to analyze to Solana and other layer ones being kind of the cloud computing backend that businesses will use? And I don't care if the website I'm looking up uses Google Cloud Platform, AWS, or Azure.
Yeah, for those kinds of services, I don't think they'll care. For liquidity, they care about liquidity. Like, so margin, like liquidity, like, is going to want speed and reliability, and margin wants liquidity. So like those things are tied together. And I think there's real demand there for going faster. But on the governance token, like, how often are you going to vote, right, or upvote per like imagine you had Reddit and every subreddit was in a different shard. Those upvotes are not in this tight of a financial market where cross shard settlement is going to impact liquidity, right? Like, so that is like a slightly less important for, like, if you had a BTC USDT market and an ETH USDT market on separate shards, and you have to take hedging positions between them, and you have to shuffle USDT between those two, and waiting 20 minutes for cross shard settlement is just going to kill you, right? Like, that is a different problem than financial trading. So how important is tech there? I don't know. Yeah, like that's going to vary. I think for video games, that might matter more, because users typically don't like waiting, to switch servers and things like that. And kind of the bigger single group you can get, there's some aspects to social networks that are more interesting. like you see Telegram with 80,000 members per group. That is the difference between, WeChat and Telegram, where WeChat, you have 500 members maximum. It just becomes a different experience.
There are very few use cases where it really matters, and I think cloud gaming currently is one of them. Maybe autonomous vehicle driving, if there has to be some transmission, is one of them. So do you envision the future of these platforms being financial markets or a more general use case?
I think like the universal computer is by definition like an exchange, like a really fancy
Yeah.
exchange with programmable, really cool, like anybody can implement their own, custom options that are hard to price. And then that I think is a clear one. What is I think is really cool about that though is that like with Audius, right? Like artists that would typically not have access to these sophisticated like ways to monetize their music without going to a label that can give them like a bunch of options and royalties, that can actually do this without anyone involved, right? They can reuse like the Serum decks and the AMMs to, sell their revenue streams and dynamically figure out what is the actual price of this, like in an open market. I think that is pretty powerful. And even for things like building communities and stuff, I think that'll have some impact. I don't know if it matters that like what's cool is that like a bunch of the tokens traded on Serum are bridged from Ethereum. Like, but it doesn't matter that they're settled in Ethereum, right? Like if you launch like something cool in Ethereum and build a community there, you can't actually stop somebody from bridging it to Solana and trading it on a market in Serum. So, this is like a weird way where like even if somebody uses, even if there's like a great SDK for awesome gaming stuff on Flow, if Solana is a better way to trade in a decentralized way, it'll just make itself over here. It's kind of cool, right? There's a lot of like weird fungibility between software. Like as soon as you have two ecosystems, somebody will build a bridge and stuff will flow between them just on its own because it's just software.
It's kind of like how Bitcoin is being wrapped on Ethereum because
Exactly.
a better way to trade it.
Yeah.
For sure. And in regards to, again, going back with this layer one, do you believe that the future is going to be just one chain, maybe that is Solana, or do you think there will be a few dominating with unique use?
So there's some really fundamental differences in the security assumptions and censorship resistance assumptions for proof of work, Nakamoto, and any kind of proof of stake network. So I think I don't think POS or PBFT based systems can replace like store of value Nakamoto style Bitcoin. I don't think it's possible. So I think there's at least like room for each point in the Pareto efficient curve. So that to me makes sense. I don't know if there's that much like I think for trading we have the best design. Like this is the one we've been focused on from day one. How do we stuff the most market order updates? How do we have the biggest single market that people can evaluate? And how do we make that as cheap and fast as possible? I'm hoping that like, we just continue to kick ass on that, and like when that use case and there's a bunch of peripheral things will flow from that. I don't know if that's going to be the most valuable one. It's hard to say, like, but right, that to me is like the hard part. And I don't even think of like us competing with Ethereum, because it doesn't matter if, again, great community launches a coin on Ethereum, great. That is like their settlement platform, but it can be traded and at a much higher volumes and cheaper and faster on Solana. So that like more stuff entering crypto is, I think, good for everybody. And from my perspective, like I think of like Solana as like the GPU for the Ethereum like CPU, right?
Yeah, definitely love that. It's not a zero-sum game.
Yeah,
Yeah.
yeah. There's a lot of feature overlaps and like absence of Solana. So some of these use cases were on Ethereum, but with both, I think the actual space actually grows much faster.
Yeah. And I know we've talked a lot about financial markets. Uh, Maybe I'm the only one who feels this way, but I think that a lot of people think that there's more to blockchain than finance and supply chain. So I think we're curious to hear what is the use case you're most excited about?
Um, I think like the governance side is like could be really transformative. It's probably like 5 years too early. It's literally
Here
like
too.
yeah, 6 degrees 1997, right? I think. And then Facebook was 2002, 2003. Nobody could have told you in the 90s that sharing cats on the internet is going to be worth like $500 billion. So, but some people are trying this stuff. I think this idea that the internet created this like way for us to basically created a single kind of global community was a really revolutionary one. And that it created a single publishing network, like a single way for everybody to publish, was also revolutionary. And I think with tokens, I think this governance thing, like us being able to like really remove advertisement and these other kind of like parasitic like ways of monetizing like human connection, I think is a really, really powerful one. We'll probably screw it up, we're humans. There's probably something that's gonna not quite go right, but I think the overall probably gonna generate a lot of good out of it. The other side of it, I think that is definitely happening is like all the boring stuff. So
Mhm.
USDC from user demand on Solana to trade on Serum, USDC like minted $25 million. So just from demand from humans, that is like a boring use case. It's just sending them money and then they give you digital dollars. But our finance guy prefers receiving USDC to bank wires because it's faster and easier to verify, and you get instant settlement. And then like you can plug it into like a, a protocol that gives you higher returns than you can on any bank, right? Like and like that stuff is so boring, but like I think really can replace like $1 trillion industry overnight.
Yeah, payments is there's just so much room to grow there.
Yeah.
Well, thank you so much, Anatoly. It was absolutely an honor and a pleasure to have you here. I know I definitely learned a lot. Hopefully, the others did too. One last question is, how can we stay up to date with you and Solana?
Um, so there's a ton of stuff on Twitter that you'll definitely won't miss because we publish everything. So you can follow Solana on Twitter, go to our website. We'll push some Medium articles. If you're an engineer, I recommend like going into Discord. So solana.com/Discord. So folks that are building stuff, they want to code in Rust or just want to play around with some of the like interfaces, you can mint and issue tokens using the command line. Like so it's literally as easy as like you don't have to be a Rust engineer to use this stuff. So jump in our Discord and talk to us. That's an easy way to get involved.
Anatoly, for those of us that want to learn Rust or want to get more proficient in Rust, do you have any recommendation like good courses or good materials to check out?
So the Rust community is amazing. They're like just really welcoming, amazing folks. And there's a bunch of like kind of getting started in Rust tools. You just definitely just Google like Rust how to, or how do I get started in Rust? And like the first page on Google will give you stuff. But there's probably a Rust club at U of M, like right? So
I
go.
don't think so.
I would get if not like there's a ton of Rust communities online. So go talk to those folks. There's Discord servers with beginner groups. They're super helpful. Myself, as somebody that spent like 12 years programming in C, like once I had a chance to code in Rust, I never looked back. It gets so many more things right than wrong. So like I highly recommend it as like if you had to know like a programming language with strong types and no garbage collector, like the hard languages or whatever, Rust is like the one to use.
Yeah.
Awesome. Thanks a lot. Well, you have any last remarks, Ishan, before we move to networking?
Yeah, no, I think we're good. And you, Anatoly?
Yeah, like if you guys want to get involved, definitely reach out over Discord, and we have like people that want to kind of code stuff. If you have spare cycles this semester and you just want to try building something, we have grants programs available to students. So like definitely just reach out if there's anything you want to build or thinking about how you want to contribute.
Awesome. Well, Ishan and Anatoly, thank you very much for your time and for being here. Everybody, if you want to stick around for networking, make sure to have your camera and mic on. Also, if you're not, please become a buff member. It's completely free. It's a great way, to get involved in the community. We have an awesome group online. Every day there's awesome conversations going on Discord, so highly encourage you. If you feel generous and you have some crypto to spare and want to donate to us, Cameron dropped the link in the chat. You can get tax deduction by donating to us because we're a 501c3 nonprofit. And if you like what we're doing, it's a great way to support us. We lost Ishan, but Anatoly, thank you so much. You're more than welcome any other time. We run weekly events and we're probably going to keep doing it even after COVID. We're seeing the light at the end of the tunnel with COVID, but even if we go back on campus, we're still probably going to run virtual events because they're super fun. So again, you're more than welcome, and thanks again for being with us. And I hope to see you everybody in the networking session.